Okay, so sorry for the delay in getting these out, but our test is tomorrow, and these are some problems that the students can review tonight to just make sure that they're ready for our test. So we're going picking up. So there's a video in the already that I sent out. It's on my Google my YouTube channel, but we'll go problems 4 through as many as we can get in the next 30 minutes. Before I have another set of kids coming in. So Felicity used unit cubes like the one shown to completely fill a rectangular prism. So here is the unit cube, and so she's going to completely fill this table. The rectangular prism had the dimensions shown. So we have 15 units, 8 units, and 4 units. How many of the unit cubes will Felicity need to completely fill the rectangular prism? So when we're talking about how many unit cubes they're going to need to fill something, unit cubes is how much it takes to fill something up. So we're talking about volume. Um, so when we're asking how many unit cubes, volume. And it says that this is a rectangular prism. And so what we need to do is we need to look at our formula chart for volume. And when we look at our formula chart for volume, we're going to see there are two formulas for volume of a rectangular prism. There's volume equals length times width times height. And there's another one that's volume equals area of the base times height. Well, since they're giving us three, length, the width, and the height, we're going to use this one. What I want the students to do is write that formula, find it, and then decide which one they're going to use, and then write the formula just like this. And then what they're going to do is right below where they wrote the formula, they're going to substitute in the values that they know. So let's look. Do we know the value of V? No, that's what we're looking for. So I'm going to rewrite that. I'm going to put the V there, and now the equal sign, and I'm going to just fill out this formula, substituting in the values that we know. So do I know the length of this rectangular prism? Well, the length is this one right here, and it's 15 units. So I'm going to put 15 in there. Do I know the width? Yes, the width is right here. It's these 8 units. So I put in the 8. And then the height, do I know the height? Yeah, it's 4 units tall. So I need to multiply 15 times 8 times 4. So we're going to do the multiplication in order from left to right. So we're going to multiply 15 times 8. I'm going to come down here so I have some space. 15 times 8. 8 times 5 is 40. Carry the 4. 8 times 1 is 8. 9, 10, 11, 12. So that is 120. So I can write my answer here for 15 times 8, and then I recopy everything else that I haven't used. So that's 4 times 120. Now that's what I'm going to multiply. So I'm going to come down here. I'm going to write 120 times 4. 4 times 0, that's 0. 4 times 2 is 8, and 4 times 1 is 4. So my answer is 480. Um, and it's asking how many cubes. Let's see. Felicity, how many of the unit cubes did Felicity need to completely fill the rectangular prism? So that's 480 cubes. And our answer, right there, 480 cubes. Okay, so now let's take a look at problem number 5. A student constructed a cube using smaller unit cubes with a side length of 1 inch. So those are the small cubes. Those are unit cubes of 1 inch. The volume of the cube the students built was 64 cubic inches. So that volume of that cube was 64 cubic inches. What is the length of the side of the cube the students constructed? So this one's a little bit challenging, and they're going to really just have to guess and check. So let's find the formula for volume of a cube. When you look at your formula chart, you're going to see that there is under volume, there's going to be listed cube, and you're going to see volume equals side times side times side. And so let's substitute in what we know. We know that the volume of that cube is 64 inches, and they're asking us for the side. So we have to figure out what side length can we multiply together 3 times to get 64? Well, they give us some answer choices. So let's just guess. Let's pick the smallest one. So let's multiply 4 times 4 times 4, and let's see if that does it. So 4 times 4 is 16. Then 16 times 4, what is that? I'll do this right here. 16 times 4. 4 times 6 is 24. 4 times 1 is 4, plus the 2, 6. There it is. So our first guess was a good one. So the side length of a cube needs to be 4 inches if the volume is going to equal 64 cubic inches. If you had tried 16, 16 times 16 would have been way bigger than 64, because even 10 times 10 is already 100. 16 times 16 will be much more than that. And then we multiply 16 again. So this one is kind of a guess and check problem. This one is a little bit challenging, but that's the way that we're going to approach that problem. All right, let's look at problem number 6. Kennedy builds a rectangular prism with cubes that each have a volume of 1 cubic centimeter. Kennedy's rectangular prism has a volume of 16 cubic centimeters. Which rectangular prism could be the prism that she built? So she built one where the volume was equal to 16 centimeters cubed, or cubic centimeters. So we have to look at each one of these and see if it has 16 cubic centimeters. All right. So we can use the formula, because these are all rectangular prisms. We can use the formula volume equals length times width times height. But the other thing we can do is just kind of count. We can see this rectangular prism has 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 cubes on that first layer. And when we count the number of layers, there's a layer, there's a layer, there's a layer, there's a layer. So there's 4 layers. So if there's 8 cubes in each layer times 4 layers, that's 32 cubes. So could that be the possible answer? Nope, because the volume that she had was 16. So we know that one's not right. So let's check this one. Here is 1, 2, 3, 4, 5, 6, 7, 8. 8 on each layer, and then how many layers are there? There's 1, and there's 2. So 8 times 2, that gives us 16. So this one could be the possible answer. But let's check these others just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 cubes on each layer, and there's 1, 2 layers. Well, 16 is what we're looking for. If we multiply it by 2, that's not going to be our answer. So we don't even need to worry about multiplying it. And then let's count this last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 on each layer, and there's 1, 2, 3, 4 layers. So again, we're looking for a volume of 16. The first layer already has 16, and then we're going to multiply it by 4. I don't think we're going to end up with 16. So the easy answer choice is going to be G. The real issue here is making sure that we are reading and understanding that question. Which rectangular prism could be the prism that she built? And it would have had 16 cubic centimeters. All right, let's take a look at another one. Number 7. Braden is building a rectangular prism. He builds a base with 32 unit cubes as shown. So if we count these, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in each layer. 1, 2, 3, 4, or in each row, and there's 4 rows. 8 times 4 is 32. Okay, I see the 32 cubes in this first bottom layer. Nice. Braden's completed rectangular prism will have a volume of 128 units cubed. So that is the volume. This is the volume of his final product. How many layers will Braden need to build to complete the rectangular prism? Well, I'm looking at the answer choices here, and 64 layers and 96 layers, they sound really large. So I think it's going to be one of these two. But if we're trying to get to 128 cubes, and if there's 32 cubes on each layer, then we just need to multiply by the number of layers. So we'll try layer 2 first and see if it gives us the 128. 2 times 2 is 4. 2 times 3 is 6. 64. Well, we know that's not right because 2 layers only gives us 64 cubes. So let's check the 4. So let's 32 in each layer times 4 layers. 4 times 2 is 8. And then 4 times 3 is 12. 128. And that's what we're looking for. So we know this is our answer. So we can check our answer choices. But another thing that we could have done, there's another formula for volume. Volume equals area of the base times the height. And that's what they're giving us here. When they're giving us the number of cubes in the base, they're giving us the area of the base. So if we substitute in what we know into that formula, we know the volume, they give it to us. It's 128. So we put 128 unit cubes as the volume, and we know that the area of the base, that's 32, because they told us how many cubes are in each layer. And what we're doing is we're looking for the height. So we're only missing one thing. So this looks like a fact family. So we can rearrange our fact family to find h. And the way we do that is 128. We divide it by the 32, and that's going to give us h. So let's quickly do that. We put the 128 under the division symbol and the 32 outside. So we ask ourselves, how many sets of 32 can go into 1? Well, that's 0. 0 times 32 is 0. We subtract, bring down the 2. How many sets of 32 can go into 12? Well, that's 0 because 32 is bigger than 12. So 0 times 32 is 0. We subtract, and then we bring down the 8. So now what we have to do is figure out how many times we multiply 32 to get to 128. And we know from our problem over here that it is 4. 4 times 32 is 128. And we have a remainder of 0. So it's going to take 4 layers to get to a volume of 128 if we have 32 layers, 32 cubes in the bottom layer. All right, let's look at this number 8. And that might be, no, we can get them all. So let's look at number 8. I'm going to switch colors over here. Coach Hubbard's track team has a storage container for their equipment. The container and its dimensions are shown below. So we have a height of 6 feet. That's this dimension right here. And we have a base. Ooh, this B is a capital B. And you'll notice that it's 49 square feet. So this is this area, the whole thing on the bottom, not a length and a width. That would be listed in feet, lengths and widths. This is base, and it's listing as square feet. So we know that that's an area. What's the volume of the storage container? Well, before we said there's 2 formulas for volume, and you'll find them both on the formula chart. One is volume equals length times width times height, and the other one is volume equals capital B, area of the base, times the height. Well, since they're giving us the capital B and they're giving us the height, it makes sense to use this one. So let's substitute in those numbers. And please, if you're working with your students, or students, if you're watching this, write the formula down and then substitute in what you know. So right below where you write the formula, you're going to write in the values for those letters. So do we know the V? Do we know the volume? Nope. That's what we're asking for. So just rewrite the V because we don't know. Do we know the capital B? Don't forget your equal sign. Do we know the capital B? Yes. They tell us base is 49. So I'm going to put the 49 in there. Then we write our multiplication symbol. Do we know the H? Yes, H is height, and they tell us it's 6 feet. So we write that in. So if they're looking for the volume, all we have to do is multiply 49 times 6. So let's do that. 49 times 6. So before we do this, let's just talk about quick estimation. 49, that's really close to 50, isn't it? All right. So if we skip count by 50s 6 times, we're going to get really close to our answer. Now, we know that 50 is just a little bit bigger than 49. So when we skip count by 50, our answer is going to be just a little bit bigger. So let's skip count. 50, 100, that's 2. 150, that's 3. 200, that's 4. 250, that's 5. 300, that's 6. So we're at 300. The answer should be someplace close to 300. And we know that 300 is a little too big because we overestimated the 49 at 50. So what's the closest answer to 300? 294. And so if choice J wasn't there, I would just pick 294. But since it says none of the above, maybe they're trying to trick us. So let's go ahead and multiply it out. But if that none of the above wasn't there, I wouldn't even multiply. I know my estimation is close. So 6 times 9, we know that's 54. 6 times 4 is 24, plus the 5. 25, 26, 27, 28, 29. Boom, right there, 294. See, our estimation was good enough. I knew it would be. I knew it would be. So this isn't hard stuff. The hardest thing really is the multiplication. Got to find the formula. Got to read the problem. Got to substitute in the numbers for the letters, for the variables, and then do the math, the multiplication. All right, 1134. I got just a little bit more time. Let's answer these, and then we will get them sent out. Number 9. I don't know if this is the last one. I think there's 10. Yeah, we have 2 more. Sam made a rectangular prism using cubes with edges that measure 1 inch. So this is going to be a unit cube. The length of the prism's base was 9 inches. I'm going to write these down. Length equals 9 inches. And the width of the prism's base was 6 inches. So width equals 6 inches. Sam built a rectangular prism without any gaps. Her completed prism was 4 layers. 4 layers. So that is telling us our height. What is the volume of the prism? Well, they're giving us length, width, and height. And so we know we have a formula, volume equals length times width times height. We also have one that's volume equals area of the base times height. But since they didn't calculate that area of the base for us, might as well go ahead and use the formula where the variables line up with what they give us. So let's substitute in. Do we know the V? Do we know the volume? Nope, that's what we're looking for. So just rewrite it. Do we know the L? We sure do. That's a 9. Do we know the W? Yes, we do. That's a 6. Do we know the height? Yes, we do. That's a 4. So we do this in order from left to right. 9 times 6, 54. And then we recopy the rest of the problem. All right, since we have to fill this one in, we have to type in an answer. This one, we're going to just have to multiply it out. 54 times 4. 4 times 4, 16. 4 times 5, 20. Plus that one, that's 21. So we would type in 216. 216. And if we had to use the units, that would be cubic units. Or we could write units cubed. Or we could write units to the 3rd power. All of these are acceptable ways to express the units for volume. That's number 9. We only have one more. All right, let's knock this one out. Francisco built a cube using smaller cubes with a side length of 1 centimeter. He used 125 cubic centimeters in all. 125. Which cube did Francisco build? So if he used 125 cubic centimeters, that means that the volume is 125. All right, so we know the volume. And since they're all cubes, if we look at our formula chart, we know the formula for volume of a cube is volume equals side times side times side. We find that on our formula chart under volume. There's two solids listed under volume. There's cubes and there's rectangular prisms. Since they tell us it's a cube right there, so we need to select the formula for cube. So let's substitute in what we know. We know the volume is 125. Do we know the side lengths? We do not. So we can just write S times S times S. Now, the thing that kids are going to do, the things that students, the mistake they make is just instead of multiplying, they add. But we don't know which one of these is right. So we're just going to pick. We're gonna guess and check. So we're gonna say, well, let's try 5. Let's just try 5. Or you know what? We could try 3. Let's try 3 first. So we're gonna substitute in 3 times 3 times 3. Let's do the math. 3 times 3 is 9, and I recopy the rest of the problem. 9 times 3, that's 27. Is that the volume that they were asking for? No, they were asking for 125 cubic centimeters. So let's try another one. We'll do it on this side. 125 equals side times side times side. So we substitute in, let's try the 5 this time. We'll try 5 times 5 times 5. So 5 times 5 is 25. Then we do 25 times 5. Well, let's do that down here. Let's set it up like a multiplication problem. 5 times 5 is 25. Carry the 2. 5 times 2 is 10. 11, 12. 125. And that is what we're looking for. So this is going to be our answer. That's going to be our answer. If we had tried 15 times 15 times 15, when we multiply 15 times 15, we can, and we need to multiply it again. So 5 times 5 would be 25. 5 times 1 is 5, 6, 7. Okay, we're done with this 5. Now we're going to multiply by the 1. We put a 0 here. 1 times 5 is 5. 1 times 1 is 1. So this becomes 5, 12, 225. So that's way too big. It's 100 too big. So we know that's wrong. And since this one is 15, it's too big. 25 is going to be way too big. All right. So I'll resend the PDF of each of these problems, but tomorrow the test is tomorrow. So the test is on Thursday, January 30th, and today is Wednesday, January 29th. So if you have an opportunity for students to watch this and get a little bit of a review, we're doing some of this in class today. Check it out and review. But tonight, if you have an opportunity to go through it together with your student with your family member, do so, because tomorrow you get to show what you know. All right. Well, I wish you guys the best.